Hello all, let's start with exercise number 12.3, question number 13. In this case, a square OABC is inscribed in a quadrant. As you can see in this figure, if OA is 20 centimeter and OC will be 20 centimeter as it is a square, find the area of the shaded region. So in this case, we need to find the area of the shaded region. We can't find the area of quadrant in this case. Why? Because we are not given with radius. So for finding radius, we need to make use of Pythagoras theorem here. As you know that the corner angles are equal to 90 degree. So in this case, we can easily find OB, that is a hypotenuse in this case. We are given with perpendicular. No, yeah, we are given with perpendicular, that is 20. We are given with base, we can find hypotenuse in this case. So I will use Pythagoras theorem here. So it will be OB square, that is hypotenuse square, perpendicular square, that is AB square, plus OA square. So OB square equal to AB square, AB is 20, OA is 20. So 400 plus 400 equal to 800. So OB will be equal to under root 800. Now when you factorize this, you will get your value as no need to factorize this, you can write it as 400 into 2. So we can write 400 as 20 square into 2. So it will be square gets cancelled out with under root. So it will be 20 under root 2 centimeter. That means my hypotenuse is 20 under root 2 and you can consider it as a radius of a quadrant OPBQ. Now for finding area of shaded region, we need to take area of quadrant is equal to area of quadrant minus area of square. So that will be your shaded region. So area of quadrant is theta over 360 degree, that is 90 over 360 into pi r square. Pi we need to take as 3.14. R in this case is 20 under root square minus area of square, that will be 400. 20 into 20 is 400. So this will be 1 by 4. And when you solve this part, you will get your answer as 800. So when you reduce this whole, you will get your answer as 228 centimeters square. Now let us move on to question number 14. Now as you can see in this figure, you are given with two sectors here. That is sector OAB and the another smaller sector is COD. So we need to find area of the shaded region. So we need to take area of sector OAB first and then take away area of sector OCD from it. So area of shaded region will be area of sector OAB minus area of sector OCD. So area of sector is 30 over 360 into pi r square, so 22 over 7. R in this case is 21 square, and in the second case it will be again 30 by 360 into 22 over 7 into 7 square. So this will be you can take this common 30 over 360, or you can reduce it to 1 by 12. 1 by 12. So you can take common 1 by 12 and 22 over 7. So you are left with 21 square minus 7 square. So when you solve this part, you will get your simplified answer as 308 over 3 centimeter square. Let's do question number 15. So it says ABC is a quadrant of a circle of radius 14 centimeter and a semicircle is drawn with BC as diameter. Find the area of the shaded region. So first of all, I will find what my BC is. So for finding BC, we need to use Pythagoras theorem here as it is a 90-degree angle here. So let's start with it. So BC square, that is a hypotenuse. Perpendicular is AB square, base is AC square. So AB square is 14 square, AC square is 14 square. It will be twice of 14 square. Now when you take square to the right hand side, it will be under root. So under root to 14 square. So square and under root gets cancelled out. So it will be 14 under root 2 centimeter. So my BC, that is the diameter of above semicircle, is 14 under root 2 centimeter. Now, first of all, we need to find the area of quadrant, this part. So area of quadrant, as you know, the angle for quadrant is 90 degree, 90 over 360 into pi r square. So 22 over 7, r square is 14 into 14. So 1 by 4, 2, 4 and 2 will be 1 and 2, this will be 7. So 22 times 7 is 154 centimeter square. Now we need to find this segment part, the divided segment. So area of segment made by hypotenuse of triangle will be 154 take away 98. That is the part of area of triangle. Area of triangle in this case is half base into height. Let me find out that as well. Area of triangle is half base into height, that is 14 times 14. So 7 times 14 is 98. So 154 minus 98 will be 56 centimeter square. So now we get a segment part of this. Now we need to find the area of shaded portion in this case. So first of all, I will find the area of semicircle, that is this part. This is the area of semicircle. Then I will subtract this value from area of semicircle. So area of semicircle will be half pi r square. Half pi is 22 over 7. R is, in this case, is 14 under root 2 square. So when you solve this, you will get your answer as 154 centimeter square. Now we need to take away area of segment from area of semicircle. So segment part is 56. So 154 take away 56 will be 98 centimeter square. With question number 16. So in this case, we need to find the area of the designed region common between the two quadrants. So we need to basically find this path of this particular shape. So in this case, I would be making a right angle triangle here. Like as you can see that angle B is a right angle triangle. So that means my ABC is forming a right angle triangle. That means I can apply Pythagoras theorem here as well. So in this case, my hypotenuse isn't given to us. So it will be AC square, AB square plus BC square. So it will be 8 square plus 8 square. So this can be written as twice of 8 square. So AC square. Now we need to take square to the right hand side. So it will be 2/8 square. So square and under root gets cancelled. It will be 8 under root 2 centimeter. That means my AC is equal to 8 under root 2. Now we need to find AM as well. We need to find BM as well, and we need to find BMC as well. So as you know that the diagonals of square bisect each other, that means my AM is equal to MC equal to BM. That means it should be half of AC in this case. Half of 8 under root 2 will be 4 under root 2. That means my AM is 4 under root 2, my MC is 4 under root 2, my BM is 4 under root 2. Now what next step is, we need to find area of triangle ABC. So let's find area of triangle ABC. So we'll be using half base into height. So half into 8 into 8. So it will be 4. 4 times 8 will be 32 centimeters square. Now, as you can see, we need to find half area of shaded region. So half area of shaded region will be area of quadrant, take away area of triangle ABC. So let us find that. Let me again tell you with the help of figure. So what I am trying to find is this path. So for that I need to find area of quadrant of this path whole. So half area of shaded region. So it will be area of quadrant, take away this triangle ABC. So I have to remove this part from this quadrant to get half area of shaded region. Then I will make it twice. So area of quadrant, take away area of triangle, that is 32. So area of quadrant in this case is 90 over 360 into pi r square, that is 22 over 7. R will be in this case is 8 square minus 32. So when you solve this, you will get your answer as 128 over 7 centimeter square. Now as you know that we have two designs here, so you need to multiply it with 2. So area of two designs will be twice of 128 over 7. So this will be 256 over 7 centimeter square. So that's the end for chapter 12 of class 10. Thank you for watching this video.